is review from Algebra 2, and the other half is kind of new stuff. The symmetry part of it, you have been able to look at a graph and tell if it has symmetry over the x and y axis, but now we're going to have 4 types of symmetry. The x-axis, the y-axis, the line y equals x, and the origin. So that's why it's very important when we tell you to describe a transformation that you don't just say reflect, because you can reflect over any line, any point, anything. You have to be specific. You say reflect over y, that doesn't tell me anything. Over the y-axis, y equals x, y equals x plus 3, y equals 2x. There's all kinds of different things you can reflect, so you have to be very specific. With these symmetries, in Unit 8 we talked about an even or odd degree of a function. Now this unit's going to talk about an even or odd function. Is the function even or odd? So of the 4 symmetry tests, one of them is going to test for if the function is even, and the other one's going to test for odd. And so when we get to those, I'll talk about that a little bit more. But this first one, symmetry about the x-axis. If you're looking at a picture, it's very easy to tell if it has symmetry about the x-axis. Here's the x-axis. Is it a mirror image over the x-axis? We can tell very easily that is. But when it's an equation and not necessarily a function, okay, some x's and y's and numbers all mixed up together, can be squared, cubed, rooted, anything, we have to have a way to do that algebraically because we can't always just graph it. So when you test for it algebraically, you replace the x's, the y's, with negative y. So symmetry about the x-axis, you put a y in place of a negative y. Then it says, and simplify. So once you replace the y with a negative y and simplify it, and you end up with what you started with, that means yes, that particular graph or equation has symmetry about the x-axis. If you plug it in and it doesn't end up with what you started with, then that would just be no. So when we're asking for symmetry about the x-axis, the answer would be yes or no. And we'll do some examples, and I'll show you the work that I expect. Symmetry about the y-axis. Again, we can look very easily at this graph that I drew and see that it's symmetrical about the y-axis. It's a mirror image across that line. If it has symmetry about the y-axis, it's considered to be an even function. Okay, it doesn't have anything to do with the degree. Doesn't even have to be a function. It's just it's an even function or an even graph if it's not a function. So the way that you test for that algebraically is you replace the x's with negative x. And then obviously if it was negative x, it'd be x. So it's the opposite. Whatever the x's are, you're putting in the opposite and then simplifying. And if once you simplify, you get what you started with, the answer is yes. It has symmetry about the y-axis and the graph is even. If the answer is no, then it's just no, and you move on. Then we have symmetry about the line y equals x, and this is going to have a lot to do with what we do. You did a little bit of this in Algebra 2 when you did inverses. We're going to do some inverses tomorrow. So if something has symmetry about the line y equals x, that means the two functions are inverses of each other, or the two graphs are inverses. So what you do with that is you switch the x and the y. And again, you simplify or solve to make it look like the original problem. If you can make it look like the original problem, it has that symmetry. If you can't, then it's no. So when we ask for symmetry again, the answer would be yes or no. And this has nothing to do with even or odd. Only the y-axis and the origin have to do with an even or odd graph or an even or odd function. So when you test for symmetry about the origin, which is the point 0, 0, we replace the x's with negative x and the y's with negative y. Or you make the x's and the y's opposite of what they originally were. And again, you simplify if you need to. Sometimes you don't have to simplify. Sometimes when you look at it, it's very easy to tell whether it is or is not going to be have symmetry about the origin. But sometimes you need to simplify just to make sure. Okay, so those are the ways algebraically that you test for symmetry. And if the answer is yes, when it's about the origin, it's odd. Now, you can, when you test these 4 things, the answers can all be yeses, they can all be no's. You can have 2 yeses, 2 no's, 3 yeses, 1 no, 3 no's, 1 yes. You can any combination of those. So if it has symmetry about the y-axis and the origin, then it would just be both. It would be even and odd. So that's an option also. So we're going to test all of these. about each of the axes given, and then we want to determine if it's even, odd, let's call this both, or neither. So you can have even, you can just have odd, you can have both of them, you can write even and odd, or you can write neither. And that is depending on the tests. So number one, whenever you have x times x plus y, sometimes you have to actually distribute that out. So I'm going to distribute it and say that is x squared plus xy equals 1. Because sometimes the test is better to do when it's actually distributed. It just kind of depends on the problem. And it doesn't matter which one you plug it into, but again, some of them you have to simplify because it's not as easy to recognize when you first plug it in. All right, so first, symmetry about the x-axis. That means we make the y's negative. So x times x minus y equals 1. So if we were to distribute that, x squared minus xy equals 1, those are not the same. So the answer for letter A would be no. This right here would be the work I need to see. That right there is what I'm looking for. Did you do the test? A yes or no will get you no credit. Okay, you have to show the test. Then letter B about the y-axis. So that means we make the x's negative. So negative x plus y equals 1. So if we were, again, that's what I would expect to see at minimum. If I distribute that, x squared minus xy equals 1, that is not the same. So it does not have symmetry about the y-axis. That also means it's not going to be even. Letter C, y equals x. So we switch the x's and the y's. So y plus x equals 1. So that ends up y squared plus xy equals 1. So that's not the same either. So that's a no. And then the last one, the origin. We make the x's negative. We make the y negative. Negative times negative is positive. Negative times negative is positive. So again, I would expect this first step, but maybe you can't recognize, so go ahead and distribute it just to make sure. And so there the answer is yes. Because once I plugged in negatives, x for x and negative y for y, and I simplified, or in this case distributed, I got what I started with. So then the next question says, then determine if the graph is even, odd, both, or neither. This is the only test that determines even. If this answer is yes, it's even. If this answer is yes, it's odd. So therefore this one is odd. The x-axis and the line y equals x have nothing to do with an even or odd function. Has nothing to do with even, odd, both, or neither. The only test you do for even or odd is the y-axis and the origin. Those are the only ones that matter. All right, so the next one, y equals x. Again, showing the test is important. Do not just write yes or no, because I will tell you, you will get 0 credit for writing yes or no and not showing the test. It is also important that you show the test correctly. X squared means if we're plugging a negative in for x, then we have to put parentheses around it. Because negative x squared is not the same as negative x quantity squared. Those are not the same. So if you meant this, then you have to write it. You can't write this and say, well, that's what I meant. Okay? I can't give you a problem and say, oh, I meant to put parentheses, but I didn't, so I expect you to do it right. Okay? If I want parentheses around something, I have to write it. You can't read my mind. I can't read your mind. So when you're showing your test, just be sure you show it correctly. All right, so this first one, we're going to plug in negative. If we want to solve, simplify that, y equals negative x squared. So that's a no, because y equals x squared is not the same as y equals negative x squared. That negative x is not in parentheses. So a negative x squared is not the same as negative x in parentheses squared. They're not the same. The next one, we are plugging in a negative x in the place of x. So x is being squared. So this one is important that you do put parentheses around it because we're replacing x with negative x. And then if we were to square negative x, we would get x squared. So that answer is yes. And then y equals x, we switch the x's and the y's. So now we're not switching the x squared, we're just switching the x. So everything stays. If anything's being added or subtracted, multiplied, raised to, square root, we're only moving the letter. So the letter x goes in the y place, the letter y goes in the x place, the squared stays where it is. We don't move the squared. So x equals y squared. We could probably all tell from that point, but if not, we would take the square root. When we take the square root, it's plus or minus. So plus or minus the square root of x equals y. Not what we started with. So the answer would be no. And again, at x equals y squared, a lot of you can recognize at that point it's not the same. So I would not expect you to go on. If you want to, you can, but you don't have to. All right, and then the last one, negative y equals, in parentheses, negative x squared, which is negative y x squared, which is y equals negative x squared, so that's a no as well. So then, when we test what for even, odd, both, or neither, all we have to do is look at our y-axis and origin. The y-axis was yes, so it's even. The origin was no, so it's not odd. So this one is even. Okay, so going back here. So if it has symmetry about the y-axis, it's considered an even function. If it has symmetry about the the origin, then it's an odd graph or function if it's a function. So it's just, those are the tests that tell you whether it's even or odd. So you just have to know that. Does that help? So that is how I'm doing. So if I just said, if I gave you number 2 and I said, is this even? The only thing you would have to do is the test for the y-axis, and we expect you to know that. So if I said, is this graph odd? The only test I would expect to see is the test about the origin. The others don't matter. You don't do them all. Okay, the yeses and none of the yeses and nos matter. Those are the only ones that matter. All right, number 4, x to the 4th plus y to the 4th. This is another one where the parentheses are going to be important when you show your work. So the first one is the x-axis, so that means we make our y negative. And again, it has to have parentheses. If it doesn't have parentheses, it's not the correct test. So any even exponent we have, that means we're going to have 4 negative y's, and if we have 4 negatives, that gives us a positive. So this one does end up being x to the 4th plus y to the 4th equals 1. So our answer would be yes. Again, that does not tell me anything about even or odd. All it tells me is that it has symmetry about the x-axis. And then we do the y-axis. So that's negative x to the 4th plus y to the 4th equals 1. If you want to go one more step, you can. Again, I don't have to see that part. I just have to see that you did the test. This is the part I would need to see. And then that one is yes also. So we know it's even, at least so far, but it might be both. So we have to do all the tests, and don't just assume that once you have a yes, the rest are no. Because on this one, you can have 2 s's. They can all 4 be yeses. Okay, it just depends on the equation given. And then switch the x's and y's. So y to the 4th plus x to the 4th equals 1. So that's a yes too. Adding, doesn't matter what order you add in, it's the same. So that's a yes. And then the origin, so we're going to make the x's negative in parentheses, the y's negative in parentheses. So that one also is a yes. So now we answer the question, determine if it's even, odd, both, or neither. The y-axis tells us even, that's a yes. The origin tells us odd, that's a yes. So this one would be both. You could put even and odd, you could put even odd, even or odd, or you could put both. I'm fine with both, because those are your only choices. Questions about those? All right, and then the last part of your notes right there is just reminding you. If we ask you, so put this on the notes for a reason. If we say, is the graph even, odd, both or neither, the work that we would expect to see is not all four of them. Okay, all four of them don't tell you anything. The only ones that matter are symmetry about the y-axis tells you if it's even, so that's what you would test for if the question was even. Symmetry about the origin tells you if it's odd. That's all that matters. Those are the only two tests you would do. So if we ask you this question like this, those are the only tests we expect to see. The y-axis test and the origin test. If you showed all four, that would not be correct. That means you don't really know what you're doing. You're just doing everything that you've ever learned. And that's not the point. A lot of pre-cal is about the directions and what the directions ask. A lot of times the math is really easy. The math we just did was really easy. But knowing what to do is the important part. All right, and then that last page of your notes today, that's just for you to do on your own. Those of you that have been doing the spirals, hopefully you know some of those answers. You figure them